Okay, so this is lesson 104, uniform motion. So it's more of these motion problems that you guys love. So uniform motion and unequal distances. So as always, excuse me, as always, what you need to do is you need to start out with your equations. Distance equals rate times time, distance equals rate times time, and then figure out what your two variables are. So let's look at example 104.1. It says at 8 p.m., Achilles left camp and headed south at 20 kilometers per hour. At 10 p.m., Patroclus headed south from the same camp. Patroclus was 50 kilometers ahead by 3 a.m. What was his speed? So we know we have Achilles and we have Patroclus. So we're going to name one of these A and another one P, and then we'll go through and pick apart the information that we have in the problem. We'll pick apart the information that we have in the problem. So we know that they started at 8 p.m. Well, Achilles started at 8 p.m. He went 20 kilometers per hour. So we know rate Achilles is 20 kilometers per hour. Then 10 p.m. Patroclus headed south from the same camp. And that's important that he started in the same place. It says he was 50 kilometers ahead by 3 a.m. So 50 kilometers ahead by 3 a.m. Sorry. Just trying to get this to focus a little bit better. So 50 kilometers ahead, that means that the distance of P was the distance of A plus 50, and this is saying at 3 a.m. So we can figure out the time of Achilles and the time of Patroclus. I don't know if I'm saying that right. So Achilles started at 8 p.m., so it's 4 hours to midnight, and we're going to 3 a.m., so that's a total of 7 hours. Patroclus started at 10 p.m. and ended at 3 a.m., so his time was 5 hours. So we have information, we have rate, and we have some distance, and we have some time. Now we just need to take it and plug it in. So I'm just going to take the obvious information. TA is 7. RA is 20, and then DA, and then DP equals, we don't have any information about RP, but we do know TP is 5. Okay, we also know that D, the distance of Patroclus was Achilles plus 50, so I'm just going to plug that in. And there's one more piece that we can figure out, and that's the distance of Achilles. Since distance of Achilles is 20 times 7, we know that that's 140. So we can take that and plug that in over here. So 140 plus 50 is 190 equals the rate of Patroclus times 5. Divide both sides by 5. And we get that the rate of Patroclus is 5 times 3, 38. So his rate is 38 kilometers per hour. Okay, let's look at another example. 104.2. Rachel, hey Rachel, this problem is about you. Okay, let's see. Rachel has a 15-kilometer head start on Charlene. How long will it take Charlene to catch Rachel if Rachel travels at 70 kilometers per hour and Charlene travels at 100 kilometers per hour? This one might be easier if you kind of draw it. So when they start, it says Rachel has a 15-kilometer head start on Charlene. So Charlene is back and Rachel is up ahead. So they're headed in the same direction, but Rachel's distance of Rachel is, distance of Charlene is going to be Rachel's distance plus this 15-kilometer head start. So distance of Charlene is 15 plus the distance of Rachel. Okay, and then it also says Rachel travels at 70 kilometers per hour, so we know the rate of Rachel is 70, and we know the rate of Charlene is 100. So that should be enough information for us to figure this out. There is one other piece. It says, how long will it take Charlene to catch Rachel if they travel at 70 kilometers per hour? So since they're starting at the same time and they're going to end when one of them catches up with the other, the time is actually the same for both. So we also can say that the time of Rachel is equal to the time of Charlene. So that's all of our information that we need. So let's do our distance equals rate times time. Distance equals rate times time. And then we'll plug in Rachel and Charlene and plug in what we know. So we know distance of Rachel is equal to the rate of Rachel times the time of Rachel. We know distance of Charlene is equal to the rate of Charlene times the time of Charlene. Now that doesn't seem like it's very helpful, but now what we can do is we can put it all in terms of one or the other. Since we know up here DC equals 15 plus DR, we'll just take that and plug it in for DC. So we'll put it all in terms of Rachel. So I'm going to bring this D sub R equals 70 T sub R, and then we'll put Charlene in terms of Rachel. So distance of Charlene is 15 plus D sub R. So we're just substituting this piece in for this piece. Then we bring down the 100. And then since we know that TR is equal to TC, and we're putting everything in terms of Rachel, I'm going to just put this as T sub R. So now we have D sub R and T sub R. We have one last thing so that we can figure out the time of Rachel. Since D sub R is equal to 70 T sub R, I'm just going to take that and plug it in here. Okay, so then we get 15 plus 70 T sub R equals 100 T sub R. From there, it's pretty easy to solve. Just subtract 70 T sub R. You get 15 equals 30 T sub R. So divide by 30, divide by 30, T sub R equals 1/2 hour. The question was asking for how long will it take Charlene to catch Rachel? So we know it's going to take 1/2 hour. Okay.